Good afternoon, students. Welcome back to chemistry class. Today, we are going to study about main features of quantum mechanical model of atoms and quantum numbers. Today, we are going to study about features of the quantum mechanical model and the quantum numbers. In last class, we studied about the quantum mechanical model. It is proposed Erwin Schrödinger. So we call this Erwin Schrödinger quantum mechanical model of atom. He derived the mathematical expression about the quantum mechanical model. And finally, the solution of Schrödinger wave equation. He proposed the features of quantum mechanical model. Whatever features, first point, the energy of electrons in atom is quantized. The energy of electrons in atom is quantized. What is the meaning of quantized? Quantized means measured. Something measured. So here, which one is measured? The energy of electrons in atom is measured. The energy of electrons that having a certain value and having the certain value. In an atom revolves, you know about the atom, structure of atom, you know. The electrons revolves around the nucleus in a circular path. That is we call as the energy levels. So this energy of the orbit or energy of electrons in atom, it is measured from the Schrödinger wave equation. What about the Schrödinger wave equation? That is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V psi is equal to 0. This is the Schrödinger wave equation. By solving this equation, we get the quantized value of energy. By solving this equation, we will get the quantized value of energy. Understood? This is the first point. What is the second point? The second point, the quantized electronic energy level, it is from the result of wave-like properties of electrons. We know about the energy of electrons in an atom is quantized. This quantized electronic energy level, it is given from the result of wave-like properties of electrons. How the electrons revolve around the nucleus? It is in wave. It moves like a wave. Because electron, it is very smallest particle. They revolve around the nucleus in a wave-like manner. This is the nucleus. This is orbit. In this orbit, the electrons are revolve around the nucleus in wave-like. Okay. Due to this wave-like properties of electrons, this quantized electronic energy level, the electronic energy levels is quantized. Okay. The solution of Schrödinger equation gives the allowed energy level. The solution of Schrödinger equation gives the allowed energy level. We know about the energy level. It is n is equal to 1, n is equal to 2, 3 and so on. These are the energy levels. The Schrödinger equation, Schrödinger wave equation gives the allowed energy level. Understood? And then Third point. What is the third point? The quantum mechanics introduced orbital. The quantum mechanics also introduced the orbital. The quantum mechanics introduced the orbit. Orbit already the Bohr atom model, we know about the orbits. Okay, but here in the quantum mechanics, there is Schrodinger, Erwin Schrodinger introduced the concept orbital. Orbital. Erwin Schrodinger introduced the concept that is orbital. Orbital means the three-dimensional space in which the probability of finding the electron is maximum. The three-dimensional space in which the probability of finding the electron is maximum. Okay. So according to Heisenberg conservative principle, the exact position and momentum of an electron cannot be determined with absolute accuracy. According to Heisenberg conservative principle, already we studied about that. He proposed that the exact position and momentum of an electron cannot be determined with absolute accuracy. Okay. As a consequence, the quantum mechanics introduced the concept of orbital. The orbits, the electron revolves around the nucleus in a circular path. We call that orbits. Within the orbits, the orbitals are having. Within the orbits, the orbitals are having. Within the orbitals, the electrons are moving in a wave-like manner. Within the orbital, electrons are moving in a wave-like manner. Understood? So these orbitals, we can find out the probability of electrons maximum. We can find out the probability of electrons maximum in this orbital. Understood? This is the third point. And what about the fourth point? The solution of Schrodinger wave equation. The solution of Schrodinger wave equation which gives the wave function. The solution of Schrodinger wave equation gives the wave function, that is psi. Okay, solution of Schrodinger wave equation which gives the wave function, that is psi. Understood? The wave nature of electron present in an orbital can be well defined by the wave function, that is psi. The psi, it is well defined about the wave nature of electrons present in an orbital. Psi means wave function. It well defined the wave nature, wave-like nature of electrons in an orbital. Understood? The wave function also known as atomic orbital. The wave function also is also known as atomic orbital. So the wave nature of electrons present in an atomic orbital can be well defined by the wave function. That is the fourth point. About the fifth point, this wave function psi itself have no physical meaning. It is no any physical meaning. However, the probability of finding the electrons in a small volume, that is the three-dimensional space. The probability of finding the electrons in a small point, that point is directly proportional to the square of wave function. That is function of x, y and z. Square of wave function. That is wave function is the function of x, y and z. The electrons revolve around the nucleus in a three-dimensional manner. That is tells about the Schrodinger wave equation. We get a three-dimensional means this is x-axis, this y, and this is z. From this three-dimensional manner, the electrons are revolve around the nucleus. And there is three-dimensional space that is called atomic orbitals. These atomic orbitals, otherwise it is denoted by psi. Okay. So from the wave equation, Schrodinger wave equation, we will get the maximum probability of electrons in an atomic orbitals. Okay, maximum probability of electrons in an atomic orbital we will get from the solution of Schrodinger wave equation. Understood? These all the main features of quantum mechanical model of an atom. Let me repeat. First point, what about the first point? The energy of electrons in an atom is quantized. What is the second point? This quantized electronic energy level, it is given from the result of wave-like properties of electrons. The solution of Schrodinger wave equation gives the allowed energy levels, that is called orbits. And what about the third point? The quantum mechanical model. The quantum mechanics introduced the new concept, that is orbital. What do you mean by orbital means? Orbital means it is a three-dimensional space in which the probability of finding the electrons is maximum. And what about the fourth point? The Schrodinger wave equation gives a wave function that means atomic orbital denoted by the symbol psi. So the wave nature of electrons present in an orbital can be well defined by the wave function. Understood? And what about the fifth point? The wave function psi itself has no physical meaning. It has no physical meaning. However, the probability of finding the electrons in the three-dimensional space that is around the point, it is proportional to the square of wave function. That is called probability density. That point is called probability density. Okay, understood? These are the features of quantum mechanical model of an atom. And secondly, what about quantum number? What do you mean by quantum number? What do you mean by quantum number? Quantum numbers. The quantum numbers, it is used to identify the various energy levels available with the atom in which the electrons of an atom can reside. So quantum numbers used to identify the various energy levels. Okay, that is means various energy levels means there is n. Okay, n is equal to 1, n is equal to 2, 3. So that is the quantum numbers. This is the quantum numbers serves as identification or the numbers, the label. Numbers used to identify the various energy levels available with the atom. Okay, so the electrons in an atom is characterized by the quantum numbers. Whatever characters are there, this for example, characters means they specify the position of electron, and secondly predict the rotation of electrons or spinning of electrons, and about determine the energy of the electrons and determine the angular momentum of the orbit. This tells about the quantum numbers. These are the main characters of the electron in an atom. About these four characters identified by the quantum numbers, there are four quantum numbers are there, namely principal quantum number, number 1, principal quantum number, second azimuthal quantum number. Third one, magnetic quantum number, and fourth one, spin quantum number. The principal quantum numbers denoted by the symbol n, and azimuthal quantum number denoted by small l, and then magnetic quantum number denoted by small m, and spin quantum numbers denoted by s. Understood? The first three quantum numbers, that is principal quantum number, azimuthal quantum numbers, and magnetic quantum numbers, these three quantum numbers, it is given from the solution of Schrodinger wave function, that is psi. Okay, and last spin quantum number, it is arises due to the spinning of the electron about its own axis. The first three quantum numbers, it is given from the solution of Schrodinger wave equation, that is psi, wave function, that is psi. And then last spin quantum numbers, it is arises due to the spinning of electrons about its own axis. Understood? And today we are going to study about the principal quantum number, only. Okay, what about the principal quantum number? Principal quantum number, this quantum number represents the energy level. This quantum number represents the energy level in which electrons are revolving around the nucleus and is denoted by symbol n. Okay, and first, the n can have the values 1, 2, 3. N is equal to 1, 2, 3, etc. Okay, you know about the electrons are revolving around the nucleus in a circular path. This circular path we called as orbits or shell or main shell. Okay, the first orbit means the n is equal to 1. This first energy level, that is n is equal to 1, and second energy level means n is equal to 2, second energy level, and third energy level means n is equal to 3, and fourth energy level means n is equal to 4, and so on. Okay, so n is equal to 1, that is n is equal to 1 means K shell, n is equal to 2 means L shell, n is equal to 3 means M shell, and n is equal to 4 means N shell, and n is equal to 5 means O shell, respectively. Okay, so the quantum number n, that is represent the energy level. Energy level means the first n is equal to 1 means E1. First orbit, what is the energy level? E1. Second orbit, what is the energy level? E2. Third orbit, what is the energy level? E3. And fourth orbit, what is the energy level? E4. Okay, so the principal quantum numbers given about, it represents the orbits. Principal quantum numbers represents the orbits. Okay, this is the first point. And what about the second point of the principal quantum number? What about the second point? The maximum number of electrons that can be accommodated in a given shell or given orbit is 2n square. The maximum number of electrons that can be accommodated in a shell is 2n square. Okay, so these are the orbits. So wherever the first orbit, how much number of electrons we can accommodate? Maximum we can accommodate how much number? It is 2n square formula. It is according to 2n square formula. 2n square means when n is equal to 1, that is this is equal to first orbit. First orbit, how much electron we can accommodate? 2 into n means 1. 1 square is equal to 2. The second orbit means 2 into 2 square. N is equal to 2 means 2 into 2 square. The maximum we can accommodate 8 electrons. Okay, so first orbit we can accommodate a maximum 2 electrons, and second orbit maximum we can accommodate 8 electrons, and third orbit n is equal to 3. So 2n square formula, according to 2n square, 2 into n means 3. 3 square is equal to 2 into 3 square means 18. So third orbit, maximum number of electrons we can accommodate, 18 electrons we can accommodate it in the third orbit. And fourth orbit means n is equal to 4. So what is the formula? 2 into 4 square is equal to 32. The fourth orbit, maximum we can occupy 32 electrons. Okay, understood? This is about the principal quantum number. Already we studied about that. And what is the third point? The n gives the energy of the electron. N. The n means the orbit. This tells about the orbit. The n gives the energy of the orbits. There is En is equal to minus 1312.8 into Z square by N square kilojoule per mole. This is the energy of the orbits. N. N denotes the orbits. Okay, and the distance of the electrons from the nucleus is given by Rn is equal to 0.529 n square by Z Armstrong. Already we studied about that. These two values it measured in hydrogen-like atoms. Hydrogen-like atom means at electron only one electron spaces. Hydrogen, what is the atomic number of hydrogen? 1. So how much electrons are there? Only 1 electron. So this En is equal to minus 1312.8 into Z square by N square kilojoule per mole. That is given from the hydrogen-like atoms. Okay, hydrogen, atomic number 1, only 1 electron, so only 1 orbit is there. So this orbit, only 1 electron is there. So these electrons, energy of this electron, that is minus 1312.8 by n square into Z square kilojoule per mole. And the radius, Rn means the radius means the distance from the nucleus and the outermost orbit. That is the radius. Distance between the center of the nucleus and the outermost orbit. This distance, that is Rn. That is calculated, that is measured already from the Bohr atomic model. So Rn is equal to 0.529 divided by Z into n square Armstrong. Okay, this is about the principal quantum numbers. The 3 points having should study, very very important. Other 3 quantum numbers we will study one next classes. I hope all of you understood. Okay. So today your assignment Write briefly about principal quantum number. Very, very important question. If you are having book, you take page number 44. Students, all of you take. If you are having book, take page number 44 about the principal quantum number. Very, very important. Study and write the assignment and send me through your WhatsApp number. Okay. About the principal quantum number. This quantum number represents the energy level in which the electrons revolve around the nucleus and is denoted by the symbol N. This quantum number represents the energy level in which electrons are revolving around the nucleus and is denoted by symbol N. The first point, the N can have the values 1, 2, 3, etc. N is equal to 1 represents K shell. N is equal to 2 represents L shell. And N is equal to 3, 4, 5 represents the M, N, O shells respectively. And what about the second point? The maximum number of electrons that can be accommodated in a given shell is 2n square. The maximum number of electrons that can be accommodated in a given shell is 2n square. And what is the third point? N gives the energy of electrons. N gives the energy of electrons. En is equal to minus 1312.8 into Z square by N square kilojoule per mole, and the distance of the electron from the nucleus is given by Rn equal to 0.529 into N square by Z Armstrong. These 3 points, the first 2 points very, very important, and third point also you study because they may be asked for the one-word questions. Okay, very, very important and very, very easy questions. Study well. All of you should write. Some of the students didn't write the assignment, didn't send me through my WhatsApp number. A few students only studying and writing daily. What about others? Students, study well. This is the time to study.